Hey guys, welcome back. You guys may have noticed I went above and beyond expectations, and I don't just have a plain white slide. I put a little theme in the background just for your visual appeal. Anyways, we are going to begin Unit 5, which is primarily centered around being able to convert in and out of what's called moles. For our first slide here, just going to tell you, put your pencil down and just listen for a minute. This stuff doesn't need to be taken notes on necessarily, and I'll let you know when I want you to pick up your pencil and start taking notes again. But I just want you to listen because I'm trying to set the tone so you understand why we need to use this weird unit called moles in the first place. Okay? Now, when we pick the unit that we want to use for something, it needs to be practical, both for what device we're using for measuring and also for the scale in terms of how big of a scale we're using. So, for example, when you measure someone's lifetime, right, that's a time measurement, but you wouldn't describe the measure of someone's lifetime in seconds, all right? We'd use years or decades, and in rare cases, even centuries, all right? And so we need to make sure we pick a unit that is workable and makes sense for whatever scale we're using, all right? So with atomic mass units, right, those are useful units when comparing the relative size of different elements. So if I want to compare carbon to oxygen, I can use atomic mass units to compare how big a carbon atom is compared to how big an oxygen atom is. Okay? When I'm in the laboratory, though, you guys have to understand just how small atoms are. And the equipment I have in a laboratory is not able to measure single atoms. They're just too small to measure their mass. We can't see them. All right, so we need to pick a different type of unit in order to make this a practical measurement, so we can actually go into the laboratory and have a visible, measurable quantity. All right, so some units you guys are familiar with when with just daily lives. It's like a dozen. So a dozen of something is 12 of something. A gallon is referring to a certain number of ounces, whether it's a gallon of gas, gallon of milk, all right, tablespoon, pair. Those are our practical units because we can interchange that number. If I have a dozen cookies versus a dozen donuts, I know I have 12 cookies or 12 donuts. All right, in the laboratory, a good unit for measuring mass is something that's a practical unit, and we use typically, of course, grams. All right, so here's where I want you to actually start taking notes. How can we convert from atomic mass units to grams? And in class, you guys spent some time today looking at just that. How do we go from something as small as an atomic mass unit and convert that into a measurable quantity in terms of grams? All right, and that magic number you guys got with your calculations is what we call Avogadro's number. And that's what we call a mole. All right, so 1 mole of something means I have 6.02 times 10 to the 23rd of that something. All right, so just like a dozen is 12 of something, a mole is 6.02 times 10 to the 23rd of something. So you guys should notice that that's a very, very large number. But when we're talking about something so crazy small as an atom or molecule, we need a very, very large number to get enough of them to actually measure. All right? So 6.02 times 10 to the 23rd refers to the number of atoms or molecules needed to convert the atomic mass unit into grams. All right? So 1 mole of atoms, molecules, or ionic compounds makes a direct conversion from AMU to grams. All right, so if I know how many grams of a chemical I have, I could work backwards to figure out how many atoms or molecules or formula units I have. And I will show you guys how to do that here shortly. But that's why we have to use this term moles. It's an intermediate that allows us to move from a really abstract idea of an atom or molecule into something we can see and measure. All right? Formula or molecular mass. Now, when we talk about atomic mass so far, we've been looking at the individual elements on the periodic table. And that number that you see that for the average atomic mass is the number we will use in these calculations. All right? But typically in the laboratory, we're often using compounds of some sort, whether it's ionic or covalent. So we need to come up with either the formula or molecular mass. The way we do that, we're going to use lithium carbonate as our example. This is just one example. What I need to do first is I need to identify the mass of the individual elements in my compound. So you guys should see that I have lithium. And because these are both capital, that tells me that those are two different elements, carbon and oxygen. And I go to the periodic table and I identify those individual masses. The next step then is I'm going to multiply the mass by the corresponding subscript. Now keep in mind, subscript is referring to these little numbers here. All right, so in fact, I don't just have one lithium, I have two lithiums. So I'm going to take the mass of lithium times 2. All right, plus the mass of 1 carbon in this case, plus the mass of 3 oxygen. So I have to multiply the mass of oxygen by 3. I add those up and I should get 73.89 atomic mass units. So that would be the formula mass of lithium carbonate. So that, remember when they combine, bond ionically, I'm going to treat them like a single particle. And so 1 particle of lithium carbonate would have a mass of 73.89 atomic mass units. Okay? And that's as simple as that's how we find the formula or molecular mass. And this is an integral step in doing mole calculations. All right? Now, when we have parentheses in a formula, that's important because let's take calcium nitrate. So this formula shows 1 calcium, right? Nitrogen, 3 oxygens, and then there's the parentheses with the 2. All right? Putting parentheses around that indicates that I am treating that like a single unit. So when I look at this, I don't have 1 nitrogen and 3 oxygens. In fact, that 2 distributes to the nitrogen and to the 3 oxygens. So in fact, the way that would look is 1 calcium at 40.08, 2 nitrogens at 14.01 each, and 6 oxygens in that case, because it's not adding the 2 to the 3, it's multiplying. It's a distribution problem. So 2 times 3 makes 6, so that was 6 oxygens, and so when I add that up, I should get 164.10 AMUs. All right, and so again, at this point, we are referring to the formula or molecular mass, all right, which is still a single particle, a mass of a single particle when I show that AMU unit. All right, so quick differentiation. Formula mass versus molar mass. Formula mass and molar mass should give you the same number. Okay, all we do is we adjust our units. So if I say molar mass, remember we're taking a mole of those particles so that we can convert that atomic mass unit to grams. Whereas molecular formula mass just remains in that atomic mass unit designation. All right, so formula mass and molar mass are calculated in the same way. We just use grams if it's a molar mass. We use AMUs for formula mass. Okay, now last but not least, and I'm going to put this in better context for you tomorrow as we continue working through that ChemQuest and do some review problems together. I just want you to have this little chart in your notes. All right, and I've got about 5 minutes in which to teach you because I promised I would keep this lecture less than 15 minutes. All right, so I want you to come in with this chart ready to go and with a basic understanding of what it means. So we're going to start with moles. And I'm going to put moles in the center. All right, so moles, as I mentioned before, are kind of a really important intermediate for a lot of what we're going to do this year. So we're going to spend some time just figuring out how to calculate moles in the first place when we're given different things. All right? So moles is our intermediate. And one thing I want you to remember is the roads go through moles. And that's how we can convert from different types of things. And I'll explain that in just a second. But moles goes in the center. So let's say I have a certain number of representative particles. I'm going to put representative particles up here. Okay? So representative particles is referring to things like atoms, molecules, or formula units. Okay, so whenever you see the word atoms, molecules, formula units, etc., all right, we're just going to lump those into what we call representative particles. All right. Now, what I want you guys to know how to do is to convert into moles or out of moles from representative particles. All right, and the first thing I want you guys to write down is whenever you're going toward moles, we're going to be dividing. And whenever you go out of moles, you're going to be multiplying. So we're going to label those two arrows like that. Now, with representative particles, right, you're going to be given, so let's say I tell you you have a certain number of representative particles or you have a certain number of moles. What you're going to do is you're going to either divide or multiply by the same number. And that number we calculated today in class is 6.02 times 10 to the 23rd. Okay, so what this little chart so far is telling me is if I have a certain number of representative particles and I want to know how many moles that is, I'm going to divide my number of representative particles by 6.02 times 10 to the 23rd. That is a 3, yes. Now, if I have a certain number of moles and I want to know how many atoms I have or how many molecules I have, I'll multiply my number of moles by 6.02 times 10 to the 23rd. Again, I'll put this in better context for you guys later. Now, another way you're often going to be asked to do this is okay, my thing's being stubborn, is if you're given a certain number of grams. All right? So, if I have a certain number of grams, I can, again, convert into moles or out of moles fairly easily. And when I do so, again, I'm going to divide into moles, multiply out. But the number I use this time is not going to be Avogadro's number. It's going to be molar mass, which I just showed you guys how to calculate. So if I have a certain number of grams, I'll divide by the molar mass to figure out how many moles that is. If I have a certain number of moles, I'll multiply by the molar mass to figure out how many grams that is. And last but not least, and this will not make sense to you guys yet, but we might as well put it in here just so our chart is complete. Divide in, multiply out. Whoops, sorry about that. And this is liters of gas at STP. All right, and the number we will use for that is 22.4. And again, that number will make more sense to you later when it actually comes up. All right, so what I want you guys to have in place when you walk in the door tomorrow is I want you to know how to calculate molecular mass or formula mass, and I want you to have this chart in place so that when I introduce these calculations to you, you've at least got these notes to refer to. And as promised, this is less than 15 minutes. You're welcome.